So now let's do the harder and much more common examples where you have a set of reactions to play with. So we have these to manipulate, and our job is to figure out the heat of reaction for this equation. So this is just the oxidation of iron, as in iron rusting. So it's going to be iron solid and oxygen gas making iron 3 oxide solid. It's already balanced for you, and those balancing coefficients are going to be very important at this point because we have to make sure that not only do we have the right thing, that we have the right number of them. So different professors have different opinions on where you should start. I say start anywhere you want to. The one clue I'll give you is if one of the reaction components, if you look down in the equations that you have to manipulate and that is in multiple equations, skip it. Do the ones that are only in one equation first, because by the time you do all those, you've probably already fixed the one that's in multiple reaction equations. I need to use these equations to build this one. So I need 4 moles of iron solid on the left side. Here's the reaction arrow. So I need it on the left side of my equation. If I look at the reactions I have to play with down here, I see iron solid only in one of them. I see it in the first one. It is on the left side, so yay, I found it, and I've got it on the proper side. But this is a problem. It has a 2 in front of it, and I need that to be a 4. So how am I going to fix that? I'm going to multiply through the entire thing by a factor of 2. If I multiply all of this by a factor of 2, then I will end up getting the right number of iron solid on the left, which is 4. Okay, so I'm going to fix that one. It'll be good if I do that, which we will do it and write it out in just a moment. So let's keep going. The next thing I need is 3 moles of oxygen gas, and I need it on the left side. So I look through my equations. The only place I see oxygen gas is in the second equation, and it's currently on the right side with a 1 in front of it. So what am I going to have to do? I'm going to have to flip it over, first of all, for sure. And I also need a 3 in front of it, not a 1 in front of it. So it's going to have to be multiplied by 3 and flipped. So when you come over here to your delta H, remember that you're going to have to flip it, which is change the sign, and multiply through by 3. All right, if we do that, that'll take care of our O2. Now let's look at the product side. The only product we have in this one is 2 moles of iron 3 oxide solid. If we look at our equations, we have iron 3 oxide solid in the third equation. It is only on the left side with a 1 in front of it. We need it on the right side with a 2 in front of it. So what do we need to do? We need to flip it to put the iron 3 oxide on the right hand side. So flip it for that purpose. And then we need a 2 in front of it, whereas it currently only has a 1 in front of it. So we need to multiply that entire equation through by 2. So its heat value is going to be multiplied. It's going to be flipped, which is just going to be change the sign, and multiplied through by 2. So I color-coded this so you can see me write these out with the changes we said we need to make. So that first equation, we're going to write out down here with the changes. So multiplying through by 2. That'll be 4 moles of iron solid plus 12 moles of H2O liquid. And it is really important you keep the states of matter because we're going to be canceling out anything possible on the left and right as if these all added to one equation, because that is exactly what we're trying to do. And you could not cancel water in the gas state and water in the liquid state. They're not the same thing. They don't have the same amount of kinetic energy in their particles, so they don't have the same heat of formation to form them, so you don't get to cancel them out. So watch your states of matter. They're crazy important to make sure that you're actually canceling and combining the right sorts of things. All right, keep going. On the product side, instead of 2 moles of iron 3 hydroxide, we're going to have 4 moles of iron 3 hydroxide solid. And we're going to now have, instead of 3, we're going to have 6 moles of H2 gas. Okay, and as far as the delta H goes, we're supposed to multiply it through by 2. If you multiply through that 571.7, I'm sorry, the 321.8 kilojoules times 2, you're going to get 643.6, and it's going to stay a positive, so I'm going to stress that. We did not flip it, so we're not changing the sign. So 643.6 kilojoules for that one. All right, let's change to pink now. So for this reaction, let's apply the changes we said we need. So we're going to flip it over. So this is the reaction arrow. We're going to take the products and we're going to write those on the reactant side. So my first one is H2 gas. Well, how many of them am I going to have? Remember, you also said we need to multiply through by 3. So 3 times 2 this week is still 6 H2 gas. The other product I'm going to have is O2 gas. How many of them? There's currently a 1 in front of it, but I got to multiply that times 3. Now, something I do just for bookkeeping and making it easier look is I try to put the arrows over each other, even if that means scooching to the left a little bit. It's just easier to see, in my opinion, so that's a suggestion. Okay, keep going. Now I need the products to be on the reactant side. So that product is going to be H2O in the liquid state. How many will there be? There's 2 currently, but I need to multiply that times 3, so I'll have 6 moles of H2O liquid. And I'm going to scoot way over here. The delta H for this was 571.7 positive, but we flipped it, so it's now going to be a negative. And we multiplied through by 3. So that will be 1715.1. 1715.1 kilojoules. So again, it's because we flipped it over, we changed the sign from positive to negative, and then we also multiplied the reaction through by 3, so we had to multiply the heat value times 3. Three, 2. All right. Woo. Okay, 3, 2. So in our third equation, we're going to do that in green. We said we need to flip this equation and multiply through by 2. So the products are going to be on the reactant side now. So I'm going to have FeOH3 solid. How many will there be? There were 2 to begin with, and I'm supposed to multiply that times 2, so there'll be 4 of those. So reaction arrow. And now what used to be reactants will now be on the product side. So I have Fe2O3 solid. How many? There was 1, and we multiplied through by 2. Next, we'll have H2O liquid. How many? There started as 3. I need to multiply that times 2, so there'll be 6 moles of H2O liquid. So what about the heat value for this equation now? I flipped it, which means I need to change the sign. So it started off positive. It's now going to be a negative. I also multiplied through by 2, so that 288.6 is going to be 577.2. Okay, now, if we manipulated those 3 reactions correctly, when we add them all together, they're going to give us the equation we've been seeking. So let's go through and mark out anything that is common on the left and right as if this was all one big reaction. These are the reactants, these are the products. If it's on the left and the right, then you can cancel it out. It was just hanging out doing nothing. So let's do that. I see 4 moles of iron solid on the left. Do I see that on the right? No. The only places you see iron on the right are in compounds, not as free iron solid. So this will stay. Can't be canceled. Next, 12 moles of liquid water are on the left. If I look on the product side, I see 6 moles of liquid water here and 6 moles of liquid water here, totaling to 12, which will cancel these. So I'm going to stay on the reactant side for now. I see 6 moles of hydrogen gas on the left, and indeed I see that on the right, so that also cancels out. I see 3 moles of oxygen gas on the left and do not see that on the right, so that will stay. I see 4 moles of iron 3 hydroxide solid on the left, and I also see that on the right, so that will cancel. And what's left on the right that there is nothing on the left to possibly cancel it out is 2 moles of iron 3 oxide solid. So now I'll simply write out what you have left, and I will be all color specific for you one more time. So the iron solid we were able to get by manipulating that first equation and put it on the right side with a 4 in front of it as we wanted to. And then we were able to manipulate the second equation. We ended up with 3O2 gas on the left, right where we wanted it to be. And finally, we ended up with 2 moles of iron 3 oxide solid on the right. So we need this delta H of reaction for this equation. That was the whole point. All you have to do is what we did right here was sum these reactions up. I'm going to do that in black. To get this, you literally just, the sum of those equations is equal to that equation, so that the sum of their heat values will give the proper heat value for this reaction as well. When you add all those up, you'll get negative 1648.7.